Okay, let's start. Number one. Okay, this question is about the elements in group 2 and their compounds. Okay, about elements in group 2 and their compounds. Use the periodic table to deduce the atomic configuration of calcium. We know that calcium is in uh, group 2. So here calcium is in group 2, and then let's write here. So calcium is in group 2, and then calcium, we know calcium is in group 2, and then calcium cal oh, calcium has 20 electrons. So the configuration is 1s2, and then 2s2, and then 2p6, and then 3s2, and then 3p6, and then the last is 4s2. Okay, this is the configuration of calcium. And then write an ionic equation with the symbol how the reaction of calcium with an excess of water. Okay, when excess of water, this one, so we have to write here calcium is solid, and then plus, because it's ionic equation, we know water cannot be ionized. Why water cannot be ionized? Because water is a liquid, and then it will become a calcium ion. Calcium ion is calcium 2 plus. Sorry, calcium ion is calcium plus. Oh wait. So let me erase this one. So here we add here. So we add. Excuse me. We have to. So we have to write here calcium solid plus, and then plus H2O liquid become calcium ion, and then plus 2OH minus, and then plus hydrogen gas. Hydrogen gas cannot be ionized. Okay, so nothing. So there is no spectator ion in this one. State the role of water in the reaction with calcium. The role of the water in the reaction with calcium is water is acting as an oxidizing agent. Oxidizing agent, water causes calcium to oxidize from 0 into plus 2, and then write an equation to show the process occurs when first ionization energy of calcium is measured. Okay, first ionization of calcium is measured. Calcium, it is solid, and then it has to become calcium gas, and then the calcium in the gas state, it has to be this one become calcium positive ion, and then plus an electron minus. Okay, And then state and explain the trend in the first initial energies of the elements in group 2 from magnesium to barium. So the trend, first ionization energy decreases. Why is it decreases? Because the more down the group, more electron shells. That means if more electron shells, more shielding effect and decrease in lower nuclear charge. If lower nuclear charge, automatically the first ionization energy also decreases. Okay, and then now let's continue to the next number. The equation of the elements here is about period tree of the periodic table. State in the element in the period tree that has the highest melting point. What are the elements in the period tree? So period three elements, elements, elements from sodium to uh, argon. Argon. The highest melting point, the highest melting point, uh, period 3 is silicon. Why is it silicon? Silicon has strong covalent bond and strong covalent bond, and also silicon. So silicon has a tetrahedral structure. Tetrahedral structure means one carbon is bonded to four different carbon atoms. Silicon bonded to four silicon atoms, so they are strong. And then state the element in period 3 that has the highest first ionization energy. The highest ionization energy is element argon. Where's it argon? Argon has a complete electron in the outermost. It is 8 electrons. It has 8 electrons. And then the complete, this one, the 8 electrons, okay, 8 electrons, the shielding of argon and sodium and chlorine is the same, as they have the same electron shell. But argon, but uh, but but argon has uh, has has more nuclear charge than than chlorine. Okay, therefore it has the highest first emission energy. And then suggest element in here, the element in period 3 that has the highest electronegativity. Element that has the highest electronegativity is chlorine. Chlorine is the element that has the highest electronegativity. Has the highest electronegativity. Why is it have the highest electronegativity? Chlorine has 7 electrons in the outermost shell. It has the strongest nuclear charge. It has higher nuclear charge than uh, other elements in period 3 except argon. Although argon has the highest nuclear charge, but it is not the electronegative element. Then this occurs because argon is a argon sorry, because argon is a noble gas and does not form does not form uh, does not form a molecule or compound. Okay, so it does not form molecule or compound. And then let's continue to the next page, number 3. Okay, number 3 here. A naturally occurring sample of boron has relative atomic mass of 10.8. And then in this sample, boron exists as 2 isotopes, boron 10 and boron 11. Okay, boron 10 and boron 11. Calculate the percentage abundance of boron 10 in this naturally occurring sample of boron. Okay, in this question, I would like to ask Celine. Hello, Celine. Hello, Celine. Are you there?
Yes, teacher.
Yeah.
Yes.
Celine, can you help us to calculate the percentage abundance of boron 10 using algebra equation, simple algebra equation, to find how many percent of boron 10? Okay, so let me help you with the clue. So boron, the total of boron is 100%. And then you need to find boron 10 x percent. So boron, so B10 equals to x percent, and then boron 11 equals to 100 minus x percent. Wait, this one should give bracket. Yes. Can you find from here, Celine?
Yes, wait.
Yeah.
The abundance of boron 10.
Yes. Abundance of boron 10. We need to use,
20%.
yeah, how many?
20%.
20%. Is it, did you answer 20%? With yes, correct. So boron 10 B 10 equals to 20%. Therefore, boron 11 equals to 80%. Okay, and then state in terms of fundamental particles why isotopes boron 10 and boron 11 have similar chemical reactions. Boron 10 and boron 11, they have similar reaction. Let me ask from Nia. Hello Nia, are you there? Nia?
Yes, teacher.
Yeah. Nia, I would like to
Yes.
ask this question, the second question that you see on your screen. State in terms of fundamental particles why isotopes B10 and B11 have similar chemical reactions.
Mm,
Yes.
because
Then
because they have same nucleus.
have the same.
No, no, no. Wait, no, 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 no.
Because they have
Wait.
the same.
Uh, because they have same number of proton, same element.
Number
No,
of,
no, wait, no, no. They have the same physical and chemical property.
yeah,
Protons and electrons have same number of protons and
same
electrons.
number of electrons.
Uh, okay, electrons, yes.
Because because oh because electrons respond as electrons responsible for the chemical chemical properties of an element. So the react is based on the electrons. Okay. Okay. Now let's
Yes.
continue. Yes. Okay. Nia. Now next. Next. This one. Complete the table 2 by suggesting a value for the third ionization energy of boron. So remember this one. First is 799, second 2420, and then the third is still blank. The fourth also, the fourth is given 25,000. The fifth is 32,800. So we need to fill the value for the third. Okay, for the third, we have to refer to this one. Okay, we have to refer to the data booklet. Let's see the data booklet here. Now, from this one. Boron. Boron, let me give a marking of the boron here. Okay. Boron, wait, let me make not as a pen, as a pencil. Boron. Oh, boron here. Boron, where is the annotation mark? Boron. Okay. Boron, this one. So what is the value of the third ionization energy? Let me ask to Matthew Dharma. Yes, Matthew Dharma. Hello, Matthew. Are you there? I do not see your face. Can you turn on your camera, please, so I know if you are behind your phone or behind your laptop or behind your desktop. Hello. Oh, Matthew Dharma is busy doing something. Okay. Okay, let me ask to Atta then. Hello, Atta. Oh, Atta is not here also. Atta, are you there? Are you behind your phone? Okay, Atta is not there. Billy. Hello, Billy. Billy.
Yes, sir.
Yeah. Billy, let me ask, what is the value for the third ionization energy of boron that I already circled?
Huh?
What is the value of the third ionization energy of boron?
3660.
Yeah,
3660.
yes, it is 3660. Okay, now, so this value we just need to write on the this one, on the value here, 3660, and then write an equation to show the process that occurs when second ionization energy of boron is measured. So it means like this. Okay, it means like this. So boron here, see, boron from the first ionization energy of boron. This one, oh, sorry, not this one, boron. Now, first ionization energy of boron. This one, I do not write the gas, but it has to be gas, and then boron is the first ionization energy here, and then plus E minus, this one is called as first ionization energy. Okay, and then for the second is boron plus become boron 2 plus an electron, and then this one is become the second. So here, so we need to write the value. The value is 799. And then the second one is 2420. Oh, 20. So we do the total amount of this one is around 3219. 3219 kilojoule per mole. Explain why the second ionization energy of boron is higher than the first ionization energy of boron. Okay, after after this one, after an electron, an after the the first outermost electron is removed removed, then there is a, a big amount. Oh, sorry. Big oh after the one outermost electron is removed, there is a great amount of nuclear amount of nuclear charge that is holding the second uh, electron in the outermost. So there is a great great amount of nuclear charge that is holding the second electron in the outermost. And then what is happening? What is happening that makes the second ionization energy for the second ionization energy is bigger than the first. Okay, and now let's see this one. Let's see this one. Nickel is a metal with high melting point. State the block of the periodic table that contains nickel. For this one, let me ask to Kevin P. Hello, Kevin P.
Yes, teacher.
Yeah. What is
Mm.
the block in the periodic table that contains nickel?
Uh, the don't know.
Yeah. How come you do not know?
Uh,
2 days ago, I already explained already about this one, the block of the elements in the periodic table. The block. So it is. It
um,
is. Yes.
wait.
Yeah. We are waiting. We are waiting. It's okay. Contains nickel.
What do you mean by block, teacher?
Block. SPDF. Last time I
Oh,
oh, so you were
D block.
yeah,
D block.
deep block. Okay, correct. So it is a deep block. Okay, so for the nickel is in D block. Okay, so D block. And then explain in terms of its structure and bonding why nickel has high melting point. Okay, let me ask to Avo. Hello, Avo.
Yes, teacher.
Yeah. What is the bonding in nickel?
Mm,
What is
the
type of
bond.
bonding? Yes.
Wait.
Yeah.
The bonding.
Yeah.
Strong metallic bond.
Bonding bonding is metallic bonding. Correct. And then what would be the structure?
Hmm.
What is the structure?
Positive ion or proton.
Positive?
Positive. Iya.
No. It is a giant metallic structure.
Ya.
Yeah. Wait. Okay. Now next, this one giant metallic structure, and then draw a label diagram to show the arrangement of particles in crystal of nickel. In your answer, include at least 6 particles of each type. So here we have to draw the crystal. So here 1, and then there is a 2, and then there is a 3, and then here we draw 6 circles. These circles uh, represents a positive ion. Okay, represents positive ions. Okay, now represents positive ions, and then metallic bonding. Wait, why is it so difficult? Difficult to draw with mouse. Okay, and then there is an electron here floating around nearby the nickel. Okay, so nearby nickel here. So this one is called as mobile C electron. Okay, free of mobile C electrons. Now this one, so this is called as metallic bonding. Metallic bonding is the strong attractive force between the positive ions of metal and the negative electron. Okay, and then now let's continue this one. This question: why explain why nickel is ductile? For this question, let me ask to Janice. Janice, hello Janice.
Yes.
Yes.
Yes,
Why
teacher.
why why nickel is ductile?
Wait.
Is ductile because because yes, hello,
Yes.
because
Hello.
yes, Janice, I'm here.
Because the energy is transferred throughout the rest of the metal.
Oh, nickel is ductile because the particles of the particles are held are held by um, strong attractive forces held by strong attractive forces, and they slide over each other. So this metal nickel particles, they cannot break because they have a strong attractive force, the strong attractive force that holds them together. So when they are slide over each other, they will not break. And then, okay, before I uh, before I continue, I would like to see in this one here. Uh, Students, why none of you is turning on your camera? Because I do not know whether you are there or not. Can you turn on your camera? Yeah. So I know Nia is turning on. So I know Nia is behind the phone. Please do not shot the toward the ceiling. Yeah. Okay, Kyla. Okay. Okay. Let me continue this one. Uh, nickel. Give for electronics. Nickel forms the compound nickel 2 chloride, NiCl2. Give the full electronic configuration of nickel ion. So nickel has 20 28 electrons. It is the arrangement, the electronic configuration, of this one. Nickel goes to 1s2, 2s2, 2p6, 3s2, and then 3p6, and then after 3p6, and then 4s2, and then 3d8. This one is 28 nickel, but nickel as ion in bracket 2 plus. So the electronic configuration, nickel as ion. Okay, nickel as ion. Oh, wait, where is the question? Okay, nickel as ion. Okay, nickel as ion. The electronic configuration, the 4s, which is the outermost. So let me write nickel 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d8. Then nickel as ion, which is +2, and then the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s will be removed. So it is will be 4s0 and then 3d8. Why is it like that? Because 4 is located in the outermost shell. So the outermost shell electron will be removed. Now balance the following equation. Now it's about balancing. Balancing equation. Let me ask to who ya? Let me ask to Hayato. Hayato. Hello Hayato. Can you help us with balancing equation? Okay, Hayato. Hayato is maybe Hayato is busy. Okay. Then let me ask Kayla. Hello Kayla. Oh Kayla. Hello Kayla. Can you make the equation to be balanced? What is the coefficient? The coefficient here, this one is 6, and then for nickel hydrated 1, 6, and then here nickel chloride is 1, here is 6, and then in the HCl is 12. Oh, sorry, why HCl over there? HCl here 12. So this is the equation, and then what is the substance that can absorb these two gases, sulfur dioxide and HCl? It is sodium hydroxide or calcium oxide. So these two can absorb. Okay, and then now next on the last page. On the last page here, which change requires the large amount of energy? Lithium group 1 electron in the outermost shell. Magnesium group 2 has 2 electrons in the outermost shell. And nitrogen has 5 electrons in the outermost shell. Helium has 2, and helium is a noble gas. So helium must have the largest amount of energy to have the first ionization energy. And then next, this one, the table here, table shows some successive ionization energy. Okay, energy data for atoms of 3 different elements X, Y, Z. This one, each one you have to convert to log number. Okay, log number, and then this one, which element is calcium? Calcium element must be located in group 2. It has 2 electrons in the outermost shell. And then if it has 2 electrons in the outermost shell, it means from the second to the third, there is a huge jump, huge jumping, huge movement. And then which between X, Y, Z that has the huge jump between the second and the third, within the second and the third, it is the y. Because look at here, the second is 1370. This one become 200, become around 3000. The jump is not that huge compared to 1150 until nearly 5000. So this is the huge jump. So it means it has two electrons in the outermost shell. And then next, which element is vanadium? Remember about the vanadium oxide in contact process. Vanadium oxide, so vanadium oxide, the formula is V2O5, means the oxidation state of vanadium is positive 5. Then the number of electrons in the outermost shell of vanadium is 5. Now let's see this one. Between X, Y, Z, which one has the highest jump from 5th to the 6th? It is this one, X, because this one 6300 become 12,400, so around 600 or 6100. And then for Z, it is only from 8900 become 10,800, so nearly 1800, not more than 2000, not more than 2000. Okay, so this is the review for today, and then you are going to have the exam, going to have the test tomorrow. Okay, good afternoon, students, and you may leave the class, and you will have test tomorrow.
Thank you, teacher.
Yes, yeah. Yes, Mila. Yes, okay, Celine.